Okay, I think we should start, and maybe we could start from the very beginning. Uh, Renee, if you can tell us a little bit about you and also your experience. Do you just start working with bridges? A little bit of for how long have you been in the crypto space?
Totally, yeah. So I've been in the crypto space for about 4 or 5 years professionally now. It's been a meandering journey. I don't want to spend the whole time talking about myself, but at a high level, I started out as a chemical engineer. I worked in a refinery, and then I was a professional potato chip slicer at Frito-Lay for a while. So if you've ever eaten a bag of Lay's, you can thank me later because I was tasked with creating the perfect potato chip slice in 2013. Um, but that was roughly when the Snowden leaks happened. So if you remember when Edward Snowden kind of shared how much the government and other state actors had insights into our private lives, it changed how I looked at human rights and realized that a lot of the human rights challenges of the future would be in the digital frontier, just like everything else. And so I switched over into technology. I became a software engineer. I worked at IBM and Snapchat for about 3, 4 years until I realized I was kind of doing the same thing, the equivalent of potato chip slicing, except now I was putting dog faces on people. So it was just the same type of like, what the heck am I doing here? Is this going to advance the future? Is it going to help people? And in about 2017, 2018, I had kind of I had a sabbatical where I was looking into what am I going to do next? What is the meaningful place in tech to work in? And that's when I fell into the crypto rabbit hole. And since then, just haven't looked back. So I've been at the protocol layer for about 4 years. I started off working at Mina Protocol, which is a leading ZK Snark protocol, then worked on Celo, another layer, about 2 years. And around last year was when I met my co-founders, James and Barbara. I see Barbara in the audience as well if you want to hop on later. Um, we were working on bridges in the context of Celo and trying to create a trust minimized bridge that would work for EVM chains without having to rely on header relays. We'll get into what this means later, but at a high level, we've been thinking about Barbara and James have been thinking about trust minimized bridging for like 5 years now, and I've been focused on the problem for a little bit over a year. And so this is something that we've dedicated all of our time in the crypto space to, and it's become particularly important in the last couple of months because of the major hacks that have happened, particularly to bridges. And if you look at the three largest hacks in crypto, they are bridge hacks. They are the most recent Ronin network hack of 625 million, the Poly network hack of 611 million, I believe, and then the wormhole hack of, I think, 325 million. So we've become numb to these numbers, but realized that there has been over $1.5 billion worth of exploits related to interoperability. And so I think this is the perfect time to discuss bridge security because a lot of people are wondering, should we even bridge at all? And I firmly believe the answer is yes, and we'll get into why and how soon.
Thank you for the introduction, Pranay. And something that I would like to add for the folks that are here is that when you were working in Mina actually is this protocol that cares a lot about privacy. But the interesting fun fact is that, unless I'm wrong, Mina was the first protocol to actually implement Ouroboros and ship it and having working like in production. Isn't that right?
That's exactly right. So, yeah, if anybody's familiar with consensus mechanisms, Ouroboros is an emulated proof of work, proof of stake algorithm that IOHK actually created and wrote the first white papers for. And so at Mina, we chose Ouroboros because it's a more permissionless proof of stake algorithm where you don't have to get elected as a validator. You just have to have enough stake to be selected for a slot. And so one of the things we were very proud of when I was there is being the first to actually take this like brilliant algorithm that these teams developed and bring it to market in the context of Mina. So that is a fun fact. I'm glad you remember that.
Yeah, sometimes I remember these like strange fun facts. I love them. And
Yeah.
anyways, let's go back to bridges. And like you were mentioning, it's like there has been a lot of problems with bridges. Why are they necessary? Why we like maybe the industry say like, oh, maybe they are like too difficult, too complex to implement. Let's not use bridges, and so we are not to have problems. Is it possible, or what do you see as the value of bridges? Can we just stop using them?
Yeah, great question. I think not using bridges is like saying, man, the first cars are really dangerous. The wheels are falling off and they don't have airbags, they don't have seat belts. I don't know that they would know what those are back then when they were first inventing cars. But point being that if people said we should never drive cars, we should just go back to horses, how ridiculous would that sound, right? So technology must move forward, and at the initial stage of any nascent technology, there will always be kinks to work through. And the way I contextualize bridges is, and the kind of exploits that have happened recently is, if you look at Web 2, do you guys remember the Equifax hack where like hundreds of millions of people's social security numbers and private data was lost uh, from a leading credit provider in the United States? Well, that was a security breach. That was an information breach. And so how I would think about it is Web3 is for value what Web2 is for information. So if there are data breaches in Web2, there will be liquidity breaches in Web3. And so this is a natural part of any kind of new technology that we're working through. But the reason we need bridges is because we don't want to be maximalists. If we believe that there's going to be one chain to rule them all, then yes, we can stay within one security boundary and not do anything outside of that environment. But I think the market has shown us that's not the case, right? There are so many different network boundaries. There's Polkadot, there's Cardano, there's Ethereum, there's Cosmos, and they all need an ability to talk to each other because at the end of the day, users do not care which boundary they are within. They just want to be able to use USDC, WBTC, ADA, whatever their favorite token is, and that the tokens need to flow wherever the applications are. And I want to give developers the ability to deploy their applications anywhere they want, and then be able to bridge and use tokens wherever. So it's just like we need to expand the boundaries and create more room for free commerce. And just stopping and saying that one chain should rule them all is a bit of a short-sighted view.
That's a great explanation, and I really like your analogy about like when cars were created. That is something necessary. So even if it's like a little bit dangerous, like it needs to be continue being improved, but there needs to be these like security precautions. For example, seat belts. So even if a car crashes, like nothing else can happen. Now, like even if car crashes, most of the times, like if you have security belt, there's a good chance that uh, you are going to be all right. Um, and related to like the value, as you were saying, like they're like very, very important because like it's like countries at the end of the day. You're going to be producing like some goods and services in some specific countries, and a lot of the economy in these countries going to depends on their exports, and also like the perceived value of people that live in that country is also going to depend on the import that they can bring from other countries. And this import and export like is very related to bridges, and also maybe we can touch that later. But bridges is not only to like transfer assets, but also you can transfer information. I see that Arjun also joined us. Hi, Arjun. How are you doing?
Hey everyone, how you doing? Sorry, I had a bit of a calendar mix-up.
No worries. So to catch up with Pranay, if you could like take a couple of minutes to tell us about you, the experience that you have in crypto, and why are you here talking about bridges? How are you related to this topic?
Absolutely. So, hi, I'm Arjun. I'm one of the founders of Connext. Connext is an interoperability protocol that has been live for a while now. We've done about like $1.3 billion in volume, and we work really, really closely with Nomad. I can jump into that a little bit in a second. I've been in the space since 2016. I joined because I was really interested in the way that blockchains and other kinds of decentralized infrastructure let us build non-sovereign, non-corporate public goods. And I think there's something really important there because we live in a world where there's an increasing amount of things that we do on the internet that are valuable and that are really should be accessible to everybody. But at the moment, the only models that we have for building things in general are either to do it through a company or for a government to do it. And fundamentally, internet infrastructure is both global and shouldn't really be controlled by anybody. I started Connext in 2017 with my co-founders. And at the time, our interest was in making Ethereum and I guess the broader blockchain ecosystem usable for normal users, for people who aren't necessarily going to be whales or going to be individuals who are deeply, deeply technical. At the time, that led us pretty quickly to scalability because scalability was really like the biggest problem at the time. So we started researching layer 2 scalability in early 2018, built one of the first layer 2s on Ethereum, which was a state-owned network in partnership with ThankChain. And then over the course of the next 2 years, as layer 2 research started moving towards rollups, we became really interested in this idea of what happens if we move to a multi-chain world. and how do we make it so that users can have a seamless experience interacting with applications regardless of whatever chain they're on. So being able to use just the app without having to think, am I going to have to get from Milkomeda to Polygon, or am I going to have to transfer assets from Arbitrum to Moonbeam, is just a huge barrier for users right now. And we went live with a really simple solution for this early last year, and now are working towards a more expressive cross-chain communication mechanism in partnership with Nomad.
That's pretty cool. Thank you. So maybe like the next topic that we could like discuss, and we can bounce ideas, and also depending of like the folks that are with us that are interested, maybe we could discuss about what type of bridges are out there, like in simple terms for someone that's not super technical, and maybe what are like the different trade-offs between all of them.
Arjun, you want to take this one? Arjun has a fantastic article called The Interoperability Trilemma, which talks about the different ways bridges verify messages. I think that's probably the best place to begin.
Awesome, yeah, and thanks, Renee. Yeah, so last year we put out this thing called the Interoperability Trilemma, which describes the fact that similar to the scalability trilemma for blockchains themselves, there is an interoperability trilemma for bridges, where bridges can only be 2 out of 3 really desirable properties, those being trustless, meaning that they don't add additional trust or security assumptions beyond the underlying chain, generalizable, meaning that they can allow for passing arbitrary data between chains and allow you to do any kind of arbitrary computation. And then extensible. And by extensible, we mean being able to be deployed on many different chains quickly and efficiently without having to do a lot of custom work for each chain. And this analysis was based off of, as Pranay mentioned, who is verifying a transaction that happens over a bridge. So which set of parties is responsible for determining whether the data being passed over a bridge is accurate or not. And so there's kind of like 3 high-level approaches that we outlined at that time. Now there's 4, but the 4th is Nomad. And so I can jump into that in a second. But like the 3 approaches that we outlined were externally verified bridges, which are basically you have some external set of actors, some set of validators or some set of multi-sig participants that are responsible for relaying that data. And so that includes things like, to be honest, it includes pretty much everything that is out there right now. So it includes, like multi-chain, Celer, Axelar, Layer 0, any system that requires on like external oracles, MPC, POS, validator bridges. What else is there? There's a lot of different ways to kind of like make this happen. Threshold signature schemes, et cetera. And the limitation of these kinds of bridges is that the cost to corrupt the bridge is equal to the cost to corrupt that validator set. And in most cases, I mean, it's especially like in cases where you're dealing with chains that have a very high underlying security, the likelihood that your bridge validator set is easier to corrupt than the chain's validator set is extremely high. And so in this case, externally verified bridges are introducing a trust assumption, right? They're reducing the trustlessness of the system, and as a result of doing that, you end up with scenarios like, the Ronin bridge hack and wormhole hack and things like that, where you have external external parties that could be compromised. I guess the wormhole hack isn't the best example, but the Ronin bridge one is. External parties that could be compromised and lead to a loss of funds. The other 2 approaches are locally verified. So similar to kind of what Connext does today, things like atomic swaps, where you just have a 2-party system where people are swapping against each other. And in this case, you can't pass around generalized data, but it's easy to deploy everywhere. And then natively verified. So this is systems like IBC, where you have one chain running a light client of another chain. And these are theoretically very maximally trustless, and they're maximally generalized, but you have to kind of build new light client strategies for every chain you deploy to. Now, the last option, and I think Pranay can go into this a bit more, is optimistically verified bridges, which we're really excited about because it's a completely new model. And I wrote a little bit about this in a blog post last week, but Pranay, maybe you're the best person to kind of break it down.
Perfect. Yeah, and maybe to give a high level kind of overview and simplify what Arjun just mentioned, since that was a great deep technical coverage. Really what we're talking about is, if y'all are familiar with Chainlink and the Oracle problem, the main issue is that any blockchain cannot know what's happening outside of its network. So that it can only know what is sent to it with a transaction, and whatever its validators say exists within the blockchain. And so we need some trust minimized way to have some external information go into a destination blockchain like Milkomeda. And with bridges, what we're simply doing is we're saying the source of that external information is going to be another blockchain itself. So Ethereum needs to talk to Milkomeda. Milkomeda cannot know what's happening outside of its validator set. So we need some mechanism to be able to tell Milkomeda, hey, this happened on Ethereum. You can believe it. And based on that information, now you can do something on Milkomeda. And the simplest, most vanilla example is you lock tokens on Ethereum, and then you mint a version of those on Milkomeda, and voila, you've just bridged tokens. So what Arjun went through is kind of the different mechanisms that exist to verify that those tokens were locked on Ethereum. The first one, the simplest one, is basically trusting somebody. It's trusting somebody in the real world. It could be one person, it could be 10 people of which you trust. If 7 of them say it was good, that's enough of a threshold to trust them. Or it could be an entire validator set that is dynamic. But at the end of the day, this is all the same trust model, which is you are believing some person in the real world telling you that something happened on blockchain A, so you can do something on blockchain B. The more trustless mechanism is kind of what IBC or Cosmos uses. It's being able to run light clients on each chain and keeping the state of the sending chain on the destination so you can verify trustlessly. But the downside of this is it's very expensive. It's really hard to develop. There's just a lot of overhead. And as I mentioned with the car analogy, if you were asking for Teslas back when the Ford Model T came out, you'd be crazy, right? It's going to take time for Teslas to arrive, but we have to deal with what we have now. And so the third option, which Nomad, the project that we are working on, has pioneered is instead of fully trusting somebody in the external world, we change that model to say, hey, trust this one person. We believe that they're going to do the right thing. But what we're going to do after they send a message to Milkomeda is we're going to say, let's wait 30 minutes. Let's wait 30 minutes so that anybody else, as long as one honest other person exists in the world, can look at what they did and confirm that it was not fraudulent. If there was something fishy about what they did, that one honest watcher can submit a fraud proof on chain and stop that message, stop that cross-chain message from being processed. And so this is the fourth option. I didn't touch on local verification. Maybe Arjun can talk about that with regards to Connext. But this is the new option that we've created that is optimistic verification. But I want to be clear that this is not for free. This isn't strictly better than the other options I've mentioned. This comes at a cost, and the cost is that 30 minutes. In the other systems, you can immediately settle the message and move on with our lives. We can take those tokens and ape them into MilkySwap or any other AMM, Occam, whatever exists on Milkomeda, right? But with Nomad, you have to wait a little bit in order to see has anybody flagged fraud. In general, we feel that 30 minutes is a very little amount of time to wait to get more security. But in order to make sure that there's the best experience, we've partnered with Arjun and the Connext team to ensure that people can get instant transfers and just use Nomad as the settlement layer.
Exactly. And that gets into a little bit of the like local verification mechanism thing, where it's like one of the trustless mechanisms to be able to move funds across chains is not actually move them. Don't deal with minting and burning assets, but instead just swap. Have somebody give you liquidity on another chain in order to receive liquidity on the Argent chain. And that's kind of that's what exists with Connext right now. And you can actually extend that to doing some types of contract calls and things like that as well. Mostly user-facing things, and but then working with Nomad allows us to make it more powerful. So we get to benefit from having Nomad as messaging layer that reduces a lot of our requirements for opt-in infrastructure. And then on the Nomad side, what we do is we, rather than having you, the user, wait 30 minutes for a transfer from Polygon to Milkomeda, you would get your funds immediately. And what would happen is a liquidity provider in our system would front the capital to you and then claim the funds coming through Nomad.
Cool. This is like super insightful. Thank you, guys. So what I was thinking is that maybe we could open up for a few questions to feel what folks want to hear more about. Maybe we could go over some things that we already discussed. Maybe they're interested in hearing about some other things. And depending on the questions, then maybe we can continue jumping into other points that could be like interesting to continue discussing. So anyone in the audience, do you guys have any questions? It could be something super basic, something that you didn't understand, because bridges could be like very complex, and that's part of like the difficulty sometimes about security. And so it's completely okay to ask something super basic, and this should be like the most simple conversation that we can have. Don't worry about asking something super simple. This is like for you, and this is not supposed to be a conversation for like developers or technical people. Okay, let's go with Nick first. Hi, Nick. Can you
Hello.
hear us
Yep.
well? Cool. Yeah, tell us your question.
So my question is about the distinction between optimistic X, where X can be a rollup or a bridge, versus zero knowledge. Have you guys thought about the possibility of a zero knowledge bridge, and what are your thoughts around that possibility?
That's a great question. Thank you.
Yeah, that's a great question. And Wei-Jay is actually in the audience. Wei-Jay is working on a zero knowledge bridge as well. So maybe if you have time, Wei-Jay, you can come up and talk a little bit as well. But at a high level, this is a great question because similar to how there's optimistic rollups and ZK rollups, you may be wondering, we're building an optimistic bridge with Nomad. Is there a ZK bridge? And the surprise answer is that ZK bridges are not possible. That is a spicy hot take. And the reason I mention that is because if you're running a verifier on the destination chain, a snark verifier, for example, and you send it a zero knowledge proof, a snark, it can know that some state transition on the sending chain was valid, but it cannot know that that state transition was the canonical one. And so what this is saying is if there's a smart contract that can change, say it's a very simple smart contract on the home chain that can change colors to any color. It can as red, green, blue, yellow, purple, whatever. The honest message on the home chain, say Ethereum, may set the color on the smart contract to purple. But then I can send a snark proof to Milkomeda against that verifier contract that exists saying that the color was actually changed to orange. Well, orange is one of the valid colors it can be changed to. And so it'll verify as authentic and it'll say, okay, Pranay set the color to orange on Ethereum. But that's not what happened. I actually set it to purple. And so this comes back to the same problem that you can encode some type of logic around what are all of the possible state transitions, but you cannot know what is the exact one that occurred unless some system that has visibility into the originating chain can tell you that for sure. And so the only snark-based systems that can do a ZK bridge is recursive snark-based systems. And this is because the recursive snark actually contains the canonical state root against which you can authenticate messages. And so I know this got a little bit complex, but right now I think the only fully trustless ZK bridge that is being built is by Neil Foundation for MENA protocol. But that requires that the chain has this ability to snark around the entire global state root. There are other systems that use snarks to optimize existing bridge operations. I suspect that's why Arjun unmuted to say a little bit more about this. Wei-Jay is building one called Scalic that improves the ability. It's similar to Nomad in that it uses an optimistic mechanism, but it has some efficiency around how the Merkle root on the home chain is updated. And then I think there's also plans for a Solana ZK bridge around being able to verify all the validator signatures within the snark. And so at Nomad, we're looking at all of these systems. We have plans to include ZK optimizations in the long run, but we want to first make sure that we can deploy this optimistic bridge fully and kind of support use cases on Milkomeda and other chains before we make these improvements.
Thank you, guys.
Yeah.
Arjun?
Yeah, just a note there. You're totally right. It's like it isn't possible to just swap in ZK for optimistic here and then have this mechanism just kind of provide its own security by default because of the difference between an L2 and two sovereign chains. One thing that you can do, and I think this is something that you touched on, Pranay, is like integrate ZK into other mechanisms. And I think the one area of research that is actually quite interesting is utilizing zero knowledge mechanisms to like optimize bridges like IBC, optimize natively verified bridges. And I would say like things like IBC are effectively providing the same level of trust minimization and also the same level of they play the same role in bridging as ZK rollups do in rollups, where you're using validity proofs instead of fraud proofs to do things. Now there's a downside to this as well. Of course, like optimizing using zero knowledge proofs is great. For IBC, one of the biggest like limitations to be able to deploy IBC to Ethereum right now is that Ethereum L1 and specifically Ethereum's KW consensus mechanism is really memory intensive. And so because of that, the cost of actually running native verification on Ethereum is extremely high. And you could do this using zero knowledge proofs and drop that cost very significantly. But the downside that you run into, and this is the same downside with like other natively verified bridges like IBC, but just magnified very significantly, is that you now have to build custom implementations. And it's magnified significantly because every chain has different cryptography primitives. And not only do they have different cryptography primitives, they actually implement their cryptography in slightly different ways as well, which is a nightmare. And then not only that, but some types of consensus mechanisms are not actually verifiable in zero knowledge at all. So things like Avalanche, for instance, Snowball wouldn't be verifiable in zero knowledge unless you used a finality gadget. And so that all of that stuff adds like a lot of complexity, introduces trust assumptions, which is why we're not, we're really bullish on optimistic bridges, is that you can deploy them to many different systems really easily without having to deal with all of these like lower level assumptions.
Coming back to the car metaphor, this is kind of like if every road required a different type of car to drive it, you would have to switch cars every time you were driving on a different road. And so what we are trying to build is a simple and safe car that can drive on every road with little adaptation.
Perfect. Yeah, of
That's
course, I understand the need for the optimistic bridge, but the delay is, one of the things that will significantly degrade the user experience. And I was wondering, just a follow-up clarification on the zero knowledge is, of course, you can prove validity of a transaction on chain A on chain B, but can you also use zero knowledge perhaps to prove inclusion of that transaction?
That would have to happen by verifying the actual consensus, which would be like, it would basically be a natively verified bridge.
Gotcha. Yeah. Okay. Yeah, sounds very expensive. Okay.
Yeah. It's kind of annoying. It's like a no free lunch situation. And I totally agree. The 30-minute delay is a pain. One thing that we've actually seen, which is quite interesting, is that like because of the way that Nomad plus Connext works together, we're reasonably confident that for every single user-facing use, or not every single, at least most user-facing use cases, you can get that down pretty cheap, just using the like fast liquidity, fast like short-circuiting mechanism that Connext provides. And then what we've seen is that like basically the cases where you need to wait those full 30 minutes are cases where you need to verify the sender of the transaction on the origin chain. So like basically the transaction on the receiving chain needs to be permissioned in some way so that it can only come from a specific contract on the sending chain. And what we've generally seen, again, this is a generalization, but we've actually yet to encounter any scenarios where this hasn't been true. We've generally seen that only tends to happen in cases where like you have a DAO interaction or a market maker interaction or other kinds of like institutional or protocol interactions where people don't seem to care as much about the latency. It's definitely a generalization, but like if you wanted to do something like I want to transfer funds across chains and like swap into Uniswap, or like I want to transfer funds across chains and like I want to provide liquidity on one chain in Aave and then like borrow on another chain. Like those are mechanisms that you could figure out ways to do quickly, which is quite interesting.
And I know we got to jump to the other questions, but to quickly wrap up here, the other quick thing I wanted to mention is that 30 minutes is for Ethereum to other chains because Ethereum's block space is quite competitive. If we were going from Avalanche to Milkomeda, for example, it could be a lot lower than 30 minutes.
Thank you, guys, and thank you, Nick, for your question. So we want to move to the next question. Hello.
Hello.
Hi. If you can share with us your question.
Yeah. Sorry. Yeah. Yeah. So my question is basically like existing. In the current market, there are bridges which are used for, let's say, as asset transfer. But are there any existing bridge over which the, let's say, payload can be transferred from one blockchain to another? And if so, then how they are different from the asset transfer bridges?
Yeah, great question. I'm happy to take this one. So Nomad is a generalized message passing bridge, and it's deployed between Ethereum and Milkomeda. So the short answer to your question is yes, it exists. It's called Nomad. It's live now, and you can start building applications between Ethereum and Milkomeda that do a lot more than just send tokens. And maybe a little bit more color on this question for the audience and why it's important. It's that the important thing to understand here is that token bridging is just one application of that uses message passing between chains. So as I described earlier, really what we're talking about is getting information from one chain onto the other. And one use case for that information is we can send a message saying there were 1,000 USDC locked on Ethereum. Now mint 1,000 MAD, which is the prefix we use for Nomad, MAD USDC on Milkomeda that you can then use in an AMM. And so the way we've architected the Nomad system is there are two sets of contracts. There's the underlying core contracts as well as the token bridge contract. And the core contracts are message agnostic. It's just a way to enqueue messages within a Merkle tree and then replicate that Merkle root on another chain in a trust minimized way to be able to authenticate messages against that state root. And so it does not care as long as the message size is within the limits of what can be enqueued within a leaf. It does not care what's in the message. It's just an arbitrary byte string. But on top of this networking rails that we've built, applications like the token bridge can interact with these rails and compose business logic to do really cool things between chains. And so I think the point that Abhimanyu is getting at is you can do even crazier things like lock assets on Ethereum and issue a loan on Milkomeda without ever moving those assets to Milkomeda in the first place. And so this is just the beginning where I think people are understanding that there's going to be this future of what we call ZAPs, cross-chain applications, that do a lot more with this generalized message passing ability.
That's super interesting. And also I wanted to extend the question a little bit more of what are other use cases that there could be with the messages? Is something related to governance that also can be done there?
Yeah, absolutely. Oh, go ahead.
Oh, go ahead.
Yeah, governance is a great example because I think one thing that we're seeing right now is there's a lot of applications that are deployed. So, for example, Uniswap is deployed on different chains, right? So V3 is right now deployed on Ethereum, Polygon, Arbitrum, and Optimism. But there is not a clear way whenever there's a governance proposal passed on Ethereum mainnet to be able to propagate that update to other chains in a trust minimized way. So being able to make changes to a local system on one chain and then use trustless bridges or trust minimized bridges to then reflect those changes everywhere they're deployed is one use case that we're pursuing and that we're interested in building out, because governance is one example of an application on message passing channels that requires a high level of security. If your governance messages are insecure or corrupted somehow, there can be huge ramifications, potentially even bigger than the ramifications that happen with token bridges. And so it's really important that for these mission critical use cases, we have these secure trust minimized rails that can standardize and create a connective tissue across application deployments on whatever chain they're on.
Right. I was going to say some examples of things that people are building on top of Connext plus Nomad right now, either building or are specking out, working towards building, are so cross-chain governance is a big one. Of course, being able to do more complex things like have V tokens on any chain and then aggregate voting power on any chain and then be able to vote from any chain, which is super powerful because you don't have to pay gas on every chain. Then lower level protocol operations, so updating protocol constants on different chains, like PCV, for instance, cross-chain DEX aggregation, cross-chain vaults, basically aggregating yield across different ecosystems and then having that be reflected in a single vault, bringing Uni V3 TWAP oracles or TWAP prices to any other chain. So from Ethereum to Milkomeda, for instance, without having to introduce oracles. And I think there's basically an entire Pandora's box of really, really cool things that you can do that either fetch data from other chains or aggregate liquidity between chains and provide users with this interesting seamless experience.
One thing that I would like to ask here is, for example, when it comes to generalized bridges, is there currently, let's say, a data retention policy or some sort of tuning mechanism when it comes to, let's say, communication, which is not in form of an asset or a token, but a simple data communication, for example, in the case of IoT devices?
So the way that data is passed around between the chains specifically right now is that we don't actually post the data in raw form because that would be super, super expensive. Usually what's passed around is just a Merkle root. And then you'll emit the data as bytes in events. So you can get the historical data by looking at the chain itself and looking at events on the chain, historical events on the chain. And then you can prove that data by pushing it into the chain on the receiving side and doing a Merkle inclusion proof. That lets you cut down on this is kind of similar to optimistic rollups and things like that, where you get to kind of cut down on the cost of actually posting all of that data. But you still have proof that data is accurate.
I think this is a good point because this is a major differentiator between Nomad and validator-based systems. So as Arjun mentioned, Nomad uses the underlying chains for storage and replicates the Merkle root as the way of proving inclusion of data on the original chain. But with other bridges that use validator-based systems, they often require an intermediary blockchain that stores a lot of data on the cross-chain messages. And so in some of these systems that maybe don't use efficient methods of storing that data, there can be state bloat issues over time. And so these are the overhead costs of these systems will go up over time, and that's not often reflected in the cost of using these systems right now, which are subsidized by tokens or in order to bootstrap network effects. But over the long run, having an entirely separate chain in order to be able to facilitate cross-chain messages is a major barrier to be running a lightweight and trust minimized system.
Cool. Thank you, guys. That's some great responses. And thank you for your question as well. So any other questions from the audience? It could be like something a little bit more complex, but also we would love to hear more like simple questions. It could be like fairly simple. For example, if there are like multiple bridges and there are like multiple assets, what happened with these assets? Can you use them the same or some other things change? So feel free to ask any type of questions whatsoever. Okay, we have another one. Hello. Good, good. Please share with us your question.
So first of all, thank you for sharing this space and hosting it. Very nice to see all the development on Cardano and bridging it to other blockchains. My question is, I do know that MusliSwap, which is a DEX on Cardano, said that Milk, their token, will be connected to Milkomeda as a utility token. Can you share how exactly, and if I did understood everything wrong? Correct, excuse me?
Okay, so I can try to take that one. I don't know that much about MusliSwap. So there is going to be like multiple bridges connected to Milkomeda. There are like, for example, Connext and Nomad that are connected to other ecosystems, for example, Ethereum. So you can bring assets from Ethereum to Milkomeda. And there is also one bridge that was implemented by the Milkomeda core developers to move assets between Milkomeda itself and Cardano back and forth. So for the specific case of MusliSwap, I think they want to move their token that's native to Cardano. So it's a CNT to Milkomeda. This can be done without problems. And the utility part is like depending of like what is the purpose of their token. I'm not aware what are the features or what are the things that you can do with that token. So I will not touch on that part. But usually you can see like most of the bridges that are going to be connected to Milkomeda. And then even, for example, you can move USDC from Ethereum to Milkomeda using Nomad. And then from Milkomeda, you can move them to Cardano mainchain. So you can get to have USDC in Cardano mainnet, which is like pretty cool, and also other assets. And eventually, also you can do it the other way around. So you can have native assets in Cardano, they get moved to Milkomeda, and then from Milkomeda, they can get moved to other ecosystems. So Milkomeda, also you can see it not just for the specific case of Cardano as this EVM compatibility solution, but also you can see as sort of like an adapter for other projects that use EVM to be able to plug in and connect to Cardano. Sorry that I couldn't talk more about MusliSwap, but we don't know that many details about them. So
no, it's all good. You don't need to apologize about it, but I kind of realized there is some sort of cooperation between you guys, so I'm starting to think how exactly.
yeah, so the same way, for example, SundaySwap deploying Cardano, there's going to be projects deploying in Milkomeda, but it's not like co-development. It's just that they're building on this specific platform. So I would recommend to reach out to MusliSwap to ask more questions. So thank you. We are going to move to the next question.
Thank you.
Yeah, no problem. Thank you. Hello, Jeremy. Nice to see you.
Hi, Nico. How are you?
Good, good. So glad that you are here, and please go ahead and share with us.
Yeah, well, firstly, congratulations on the launch. It's very exciting. And I always find this topic of interoperability very interesting, mainly when you look at Cardano, asset creation on layer one. There's a lot of good benefits from the descriptions that you can have on chain. And so when you create an NFT, you can go to pool.pm, which is a type of explorer that shows you all relevant metadata. And then if we start looking at traceability solutions and just having metadata records themselves, there's a lot of clear text that can be shown, or you can interact with data hashes and digital signatures for verification. So I was just kind of curious, what would be kind of some of the unique value propositions for an asset to be created on Milkomeda as C1, and why would you do it there instead of doing it on Cardano as a layer one?
Yeah, that's a good question. And usually what we are recommending, even if you launch a project on Milkomeda, that you create like the native asset on Cardano, and then you bridge that asset to Milkomeda. So this way, like the asset can get not only exposure to Cardano, also can get exposure to Milkomeda, and even further with the use of bridges, you can also export that asset to Ethereum, Moonbeam, to the Polkadot ecosystem and many other ecosystems as well. So mostly it's about like being able to like be in multiple ecosystems, which is like practical.
Yeah, and I want to chime in here and say that I see that high level of interoperability with the existing EVM ecosystem as a great bootstrapping process for any of the layer one chains that the Milkomeda chains are connected to, because it's kind of like the English language or JavaScript or these other languages that aren't perfect but have taken root, right? It's the EVM is often a language that is spoken by a lot of developers who know how to write Solidity, and so giving them some way to onboard and deploy tokens in a format they're familiar with is a great kind of dipping their feet in the water. Without that bridge, pun intended, people often feel intimidated to try out other ecosystems. And so I'm pretty excited about Milkomeda because it not only does this for Cardano, but all the other kind of layer one chains that maybe have some really cool development going on under the hood. Like we talked about Ouroboros at the beginning for a reason. Like this is a groundbreaking consensus mechanism that was designed by IOHK, but not really well known outside of maybe the Cardano, Polkadot, or Mina ecosystems. And so I think there's a lot of these hidden gems, not only in Cardano, but in Algorand, in Terra, in Solana, that I think can be exposed to more EVM developers. And I think that's why we're excited about this partnership with Milkomeda, because it expands the realm of possibilities for developers.
So do you maintain that same level of, we'll just call it expressive metadata, when you're using a bridge? Or like what is the on-chain metadata itself? I mean, if we were talking about then like Merkle roots, would it just be a simple data hash, or how would people then, look for the on-chain record to see what assets that they're holding in their wallet?
Nico, do you want to take this one, or should I give my best shot at answering?
I could take it from the Milkomeda perspective. So, for example, for Cardano, Cardano doesn't have decimals for CMT assets. What this means that at the protocol level, all the numbers are full numbers, 1, 2, 3, up to like very, very high. You cannot have 1.2 tokens. So, but someone can tell me, oh, but I have a wallet in Cardano and I have like this specific token that says that I have 10.5. So how is this happening? So actually, part of like the metadata, and the Cardano Foundation has what is the token registry that says like, oh, actually for this specific token, you're going to see the metadata from the wallet and not the protocol from external service that's called the token registry. So depending on which visualizer are you using to interact with the chain, it should be reading this data that's like in this other repository, the token registry, that's going to say like, oh, the first three numbers for saying something, those are going to represent decimals. So for example, if you have 1,000, actually you don't have 1,000, that should represent that you have one token. And if in the protocol says 1,005, you're going to have 1.005 tokens. So the question, how do this like extends to Milkomeda? So when you're moving a token from Cardano to Milkomeda, this is going to be respected. So the information they're moving 1,005 tokens at the protocol level, Milkomeda is reading the information from the token registry. So you're actually going to be converting to 1.005 tokens in Milkomeda. So Milkomeda is acting as this adapter. So other projects from other ecosystems can understand what is happening in Cardano, because actually this is not so common. I'm not saying that it's bad, I'm saying that's common, it's uncommon. So for bridges, it's like really difficult to understand with this level of deepness what's happening in Cardano. But if they're connecting to Milkomeda, they're going to get this knowledge on code for free, because Milkomeda has already translated all this extra information for this other ecosystem that work with EVM. I hope that gives a little bit more context for the question.
Yeah, definitely. Thank you. And great talk. I'm also interested to hear about what Icon is helping in this ecosystem of Nomad and Milkomeda. It's a front end, easier to use interface.
Yeah, that's also a great question. So something that we mentioned before is that you can use Nomad, Connext, and other solutions to move assets from other ecosystem to Milkomeda, and then from Milkomeda, you need to use the Milkomeda bridge to move from Milkomeda back to Cardano. Maybe some users, they are not interested in actually using Milkomeda as an EVM solution. They just want to move an asset from, let's say, Ethereum to Cardano, and having to set up a wallet for Milkomeda. Maybe it's like kind of like annoying, and also you will have to do 2 transactions, because one is from Ethereum to Milkomeda, and then another one from Milkomeda to Cardano. So what Ion is doing is that they are putting like a front end that's going to be talking to Nomad bridge with Connext, and also in the other end with the Milkomeda bridge. So you're going to be able to move tokens from Ethereum to Cardano, from Cardano to Ethereum at once. And it's going to be like very simple for the user, because you're going to be like, for example, I want to move 5 wrap Bitcoin, or maybe not so much money, like 0.1 wrap Bitcoin from Ethereum to Cardano. And that should be fairly simple. It should be like 2 clicks. And so to have a better like user experience and better interface, they're working on this, which I think it makes sense. This is something that they're working on, and they're like one of like the multiple projects that are built in Milkomeda. This is not coming from Milkomeda itself, but in any way that we could like support them with questions and other things we're going to do, but that's their own project. And also this can go the other way around. So for example, if there's like a specific token in Cardano, it can also be moved to other ecosystem. And I heard that recently Wall Mobile Token, which is like a well-known project in Cardano, is going to be using sort of like this approach to move asset also to other ecosystem, which is like this project that I think is doing wireless in Africa. I don't remember the specific countries.
Thank you.
Yeah, of course. So let's move to the next person. Sorry, I'm going to move with STN because you already got to speak, but if we have time, we are going to try to get back to you. Thank you, Jeremy.
Enjoying the spaces. Me and Prene actually have talked before, but I'm really excited about what Milkomeda is doing as well. And I actually had a question for Prene, because the last time we talked, we had it about the Ronin bridge and about the time it took to find out the exploit happened. And I wonder what your view is on maybe making the 30 minutes longer depending on the size of, as there's currently like still not a lot of information available for anyone to verify malicious transactions. And I think that's definitely something we could talk about too. How do we make it more easy for people to verify transactions? But also if that would be a solution for these big hacks where like 600 million is stolen. I mean, is 30 minutes enough to protect such a big transaction where a lot of money is at stake?
Yeah, awesome question, Stan, and obviously great to chat with you again here. For context for folks in the audience, what Stan is referring to is recently there was the largest hack in crypto happened to the Ronin bridge, which is a bridge run by 9 validators between Ethereum and the Ronin network, which I think is used by Axie Infinity. And the kind of shocking thing here is that the exploit happened 6 days before we knew about it, before people noticed it and sounded the alarm. And so how could that be possible that $625 million was exploited and it took 6 days for people to notice? Well, I think I keep coming back to this car metaphor because it's very apt. this is such a new technology that we just do not have the observability mechanisms to be able to even identify when something fishy has happened. So coming back to the car metaphor, think about in the early days when if your car breaks down, it's probably going to take you forever to fix it because there isn't a set of mechanics. There aren't people that know how to diagnose what happened to the car and be able to take care of it within 30 minutes. So kind of if you think about today, if you get a flat, you can call AAA or whoever the emergency provider is and get your tire repaired immediately. They're standardized tires. Obviously, this metaphor falls apart once you go deeper, but the point being is that we have not developed the sophisticated observability mechanisms needed to know that something weird has happened or flag something that is kind of one or two standard deviations away from normal. But to your more specific point question, Stan, around is 30 minutes enough? The number one thing we're trying to optimize for is to provide enough block space on Ethereum to be able to confirm a fraud proof. And so the protocol engineers on the Nomad team spent time looking at kind of what would be the cost of censoring a transaction on Ethereum and basically 2x'd the amount of block space needed to get in a fraud proof reliably. I think we're planning to do a write-up on how the 30 minutes was calculated and happy to share that out once it's ready. But for the purposes of submitting a fraud proof on chain, 30 minutes is more than enough because if somebody could grief and prevent transaction inclusion in Ethereum for over 30 minutes, there are bigger things that would break under the hood than Nomad itself. At that point, we have like a DEFCON 1 type emergency for all the systems on Ethereum. But I think your point stands, which is that as we go, as we encounter exploits and issues that happen at the application level but may not actually reflect as fraud within the underlying system, how do we observe these things and make sure that it's prevented before it goes through? And one of the simplest things that we can do is just look at what is the average transaction size going through the bridge, and if something is within some bounds or thresholds greater than that, debounce it, or basically like have the engineers or watchers that are operating the system be able to know that something fishy is going on. And so I think we'll have a lot more to share on how observability can be improved within bridges. But I think because the user experience is so important, we're obviously working with Connext to expedite it and provide fast liquidity. But even at the settlement layer, more than 30 minutes is a bit of a non-starter for a lot of users. So I would hesitate to just brute force increase that and say, instead, what we should be directing our efforts on is improving observability and understand what mechanisms we can use to prevent any issues.
Yeah, because you obviously don't want to like hurt the average user, but I feel like with these very large transactions over like 100 million, there is definitely a case to make on flagging them, or maybe ways to at least observe these transactions better, because those are obviously the ones that have way more at stake than like a normal transaction of me or you just bridging my assets on like an average size.
Right. Your point is that an honest user is probably not moving 100 million in one transaction. And likely what that is somebody like rugging the system. And so if you see a transaction greater than some threshold, the trade-off here might be halt the system, have the watcher basically halt the channel in order to be able to investigate it and then set it up again if it is everything is fine. And so the degradation of liveness or the worst SLA is an acceptable outcome for users if it has even the off chance of protecting them from a major hack. I would agree with that.
Yeah, because with Ronin, it was, for example, all of the liquidity. So it was like not usual for that to be done by an average user.
Same with Wormhole. I think it's a common pattern. I think you've given me an earworm to write something about this. Let me get back to you with something more cohesive.
Yeah, I really enjoyed it, and I always love to hear you guys talk and discuss these topics. So I really appreciate you answering my question, and I'm looking forward to more of these spaces.
Well, thank you for your question as well. We are already past 8 minutes. I don't know what is your time commitment, Prane, and are you guys want to wrap up now, or do you want to take one more question or something?
I can stay on for a few minutes.
Same. I think Abi has another question that we could answer, and if anybody else has some final burning questions, please smash request now.
On top of Statan in your conversation regarding increasing some sort of a block size or putting more data, like fraud-proof data, are you guys pointing towards EIP 4844 regarding the blobs? Is that going to be, I mean, is it going to be within that realm of solution?
I'm not familiar with EIP 4884. Can you explain what that is and what you mean?
No, it's it's 4844, which instead of posting called data, they're gonna post a blob of let's say like data, and basically to increase the data availability problem as well that exists currently on layer 2 rollup especially.
Oh, got you. Oh, Arjun,
So,
you want to answer this one?
yeah. So 4844 is really cool because it allows you to like dramatically reduce the cost of rollups. And the reason for this is that like rollups need to have on-chain data availability. And so you need to, specifically optimistic rollups, and so you need to make sure that a contract on-chain is able to access a bunch of data. Doesn't necessarily need to use it, but is able to access that data to be able to run a fraud proof in the event that something goes wrong. I think so. So the idea with 4844 is that like the majority of the rollups cost right now comes from call data, because you're instead of posting the data to chain, you're basically posting the data to like you're posting all of it as call data to Ethereum, and utilizing it at some point in the future. I think there might be ways to leverage 4844 to like increase the scalability of Nomad. But I think the benefits of that EIP would be limited against Nomad's construction. I mean, it might help somewhat, but not a very significant amount, because there's just Nomad doesn't utilize call data in the same way. The state transitions that you're executing in Nomad are very, very simple because you're not actually like executing the states. Like you're not executing like an entire VM in Nomad. You're just executing state transitions between like one worker root to another.
Yeah, okay. I pulled up the EIP and I read this before. I just wasn't familiar with the number for it. But the idea here is basically if we are moving to a rollup centric roadmap, the rollups on Ethereum need to be able to post the call data more efficiently to the base layer so that in the future, if we need to load that all the state transitions and execute them to try and prove that fraud happened, we can do so in a more, I guess, efficiently packed format, hence the blobs. Nomad fraud proofs require executing a transaction that proves that whichever state root that the updater signed was an invalid one on the home chain. And so I can see how, because of the comparison between optimistic systems, optimistic rollups, and Nomad, it may seem like we would also want to make using call data more efficient. But really, the thing that parameterizes the fraud proof window is how certain are you that you can confirm a transaction on Ethereum that can then execute and prove that the updater signed state root was invalid. Having more efficiently packed data in call data is not kind of a bottleneck for this. It's more how competitive is the block space market. And so one thing we could do is we could basically make that fraud proof computation a little bit more efficient so that it consumes less gas. And so for an honest watcher, if they're going to spend the same amount of money, they would be, that gas fee that they pay is a greater multiple of what is required to include the transaction in the block. And so there, I think the key point you're getting at, Abhi, is how can we make the system more efficient so that we can reduce that fraud proof window over time. I am not a protocol engineer. I obviously didn't know what 4844 was off the bat, but there are ways we can improve this over time so where fraud proofs can be proven more efficiently and that window can be reduced.
Yeah, thanks a lot. And one last, and I think it's sort of an open question last time I checked regarding the fungibility aspects of the bridge asset. For example, WETHs cannot be regularly swapped with, let's say, some sort of native WETH or WETH coming from another bridge. Any progress on that?
Sorry, Abhi. I want to give the right to ask the next question to Technique. These ones also like very, very technical, and we want to do something for beginners, as the title hints. So thank you for the question, but we want to move forward. Hello.
Hi there. How's it going? I appreciate you calling on me and answering my question. I apologize if you don't want to answer the question. Just tell me to move on. So I've wrapped some right when Milkomeda first launched. I wrapped using Flint Wallet my ADA over onto the Milkomeda side chain, and I made some nice gains over there. And now I kind of want to come back to mainnet, and I understand that the general release of the bridge for returning to the Cardano mainnet is not released to the public, but if you know how to use command line and things like that, you can go do it. My question was simply, when I went in there to go tool around with some of the smart contracts, this isn't a beginner question, so feel free to not answer it. But when I went in there to go write the smart contract to get it back onto the Cardano main chain, I was just wondering if I write that smart contract in like an IDE, should I really be writing that on my own IDE, or if I use like a browser-based IDE, are they going to have all the information from my wallet, and I kind of just completely screwed myself over by using some other service? Sorry for a complicated question.
Oh, no, that's a great question, and I'm going to rephrase it. So in Milkomeda, you can move assets to Milkomeda, and also you should be able to obviously move assets back to Cardano. And you are like super interested, obviously, in to move assets to Cardano. So when we launched last week, I think it's like even less than 7 days from now, so much has happened. So wrapping assets work like really, really well, and we can scale very much. But we wanted to, so there's a big difference between Cardano and other EVM systems. Cardano works with what is called UTXOs, and other systems, they work with account-based. Account-based works like similar to a bank. So when you want to transfer money to someone, and for example, you want to transfer someone $37 with 50 cents, you transfer the exact amount to that person. Everything works great. UTXO works a little bit different, and it has a lot of trade-off. Some they give you like really good things, but all the things make some things more complicated. But overall, I'm like super interested in UTXO, obviously. So for UTXO, they work like when you go to a supermarket and maybe you want to pay something that's $37 with 50 cents. Maybe you don't have the specific amount, but you pay maybe with $40. So you want to have some coin change. So what happened is that Milkomeda had like really, really good growth, which is something that we were looking for. But the amount of UTXOs that were created were like, at some point, they were like around like 4,000 UTXOs, and you can think of these like coins. So what was happening is that the protocols to handle UTXOs are not efficient enough yet to do like coin handling when there is like this amount of UTXOs. And maybe you have even experienced this, not in Milkomeda, but in some wallets. For example, I have heard that Yoroi has had this issue that when you have too many assets, you cannot send something. So you need to like start doing like sort of like UTXO management indirectly, like sending transactions to yourself for like bigger, smaller amounts. So these coins that, for example, I don't know, in Cardano, if you're going to pay, for example, 20,000 ADA, you cannot use one ADA coins because that will be 20,000 ADA coins, and Cardano has a transaction size limit, and when you use too many coins, you hit that. So the problem is that the algorithm that we were using from the Cardano research library wasn't efficient enough for the amount of UTXOs that were there, and so we had to improve the UTXO management, and the team was working really hard. And yeah, even myself, I was waking up like almost every day at 4:30 in the morning to support the team in Europe. So the team was able to upgrade the UTXO management system with something that we created, and we are also going to be open sourcing that to the entire ecosystem. So hopefully some wallets are also going to be using this, so users are not to have problems with UTXO management. So now the system should be like almost caught up with like all the transactions that were like pending, because a lot of people start using like a bridge that was in development, but it could be used in mainnet, so that created like some issues. But all the money is saved. It's just that it's taking longer because we had to create this new UTXO management algorithm and then synchronize with validators to update it. So hopefully in the next day, or even maybe today, if we're lucky, there's going to be like a specific webpage, which is cardano-bridge.milkomeda.com, that you're going to be able to use to move assets from Milkomeda back to Cardano. And right now, the team is testing that everything works fine with the new UTXO management system. Hopefully that sort of answers your question and also gives more insight to the overall community.
Thank you so much. Yeah, no, that was a very detailed answer to my question. So awesome. I mean, the public release will be maybe today, maybe tomorrow. I'll look into the smart contract question I had. So my other question now, just because you brought that up, and again, I cut me off if I'm monopolizing any of the time. I realize it's a public space, but will that mean that I can USDC back to the Cardano mainnet using that same bridge, or is that only going to be for ADA?
Yeah, that's a good question. So in partnership with, I don't know if it's public yet, so I don't know how to say who it is, I guess. But the idea is that also through their work, Milkomeda is going to be able to move together with Nomad assets to Cardano. So even if you never get to use Milkomeda at all as a Cardano user, you're going to get exposure to USDC, USDT, Wrap Bitcoin, and among other assets because of like this specific partnership that are going to be bringing these assets to Cardano, and Nomad is also part of that.
Very cool. Thank you so much. And what about NFTs? Can you move NFTs over, like an ER721 over to Cardano?
Right now, I think that's going to take a little bit more time because the priority is in like a different type of tokens. And basically, Milkomeda is not only these EVM capabilities, sidechain for Cardano, but also this adapter for other projects to be able to connect to Cardano. So the priority of the core developers right now is to like being able to have this adapter as good as possible. And this right now the main focus is in performance for the wrapping and unwrapping. And as I was mentioning, that happened with the rework of the UTXO management system that also is going to get open source, and also with everything related to like the conversion of metadata from Cardano, the token registry, from Milkomeda back and forth for like everything that's related to like decimals and some other
Very cool.
that's,
Thank you so much.
important.
I'm about to lose service. I appreciate it.
Yeah, no problem. And I don't think we have any more questions, so I'm going to give the word to Pranay and then Arjun, so we can wrap up.
Thanks, Nico. Yeah, I don't have too much else to add. I know this is a very big topic around security, and bridges in general they have grown, and TVL and usage has exploded a lot faster than general awareness and understanding of them. So I am really grateful to you and Milkomeda team for hosting this and helping educate people and get the word out there, as well as give a platform for me to talk about Nomad and what we're doing to improve security. We're really, obviously, you've heard it from me before, but we're excited to be working with you all, and excited to go wherever Milkomeda goes. And so, yeah, I'm excited to do more of these. And if folks have specific questions around bridging or security, you can always hit me up on Twitter or Discord. Please also follow Nomad on Twitter and join the Discord. We have a growing community that is excited about these topics, and please join there to engage with our Nomad lads. Thanks.
Yeah, thank you so much for hosting us. This is really awesome. Be sure to join the Connext Discord as well. Happy to answer any questions that you guys might have. And yeah, thanks everybody.
Thank you, guys. It was really fun, and hopefully also for the folks that got to join, or the ones that are going to be listening to the recording, hopefully this was helpful. Please leave comments about what type of things you would like to hear for next time. And until then, thank you, everyone. Bye.